All right, here's a quick video to show you what I'm looking for in the um, light and temperature change lab data analysis assignment. So we gather data on how light affects the temperature of the cup. And now I'm asking you to think about how light may or may not be entering into the cup. So you're going to have 5 drawings that you need to do, and these are little models, zoom-ins of the cup wall with a ray of light hitting it. Okay, and so up here you can see in our key are different rays of light. So if all the light is coming in, it's a complete arrow. If most of the light is moving through, it's most of the light, it's a dashed line. As the light diminishes, we get more and more dashes or fewer bits of the line, okay? If the light is completely absorbed, then it's not going to have an arrow at the end. It's going to go from a complete line to a partial line. So each one of these zoom-ins is of a specific situation. So this is your clear plastic cup with the light. This is a clear plastic cup in the dark. So you might imagine that if it's in the dark, is there light actually hitting our cup? And the answer to that is no. So there is no light. No light. So you might want to scratch yours out. So let me go back here to our clear plastic cup and what I'm looking for. Remember, we're going to label things. So this is a ray of light. This right here, the thick part, is the wall of our cup. Cup wall. And the question that we're asking you to illustrate is what happens to this ray of light when it hits the wall? Does it transmit completely through the wall to the other side? Does it get reflected off in some way? Does some combination of the two happen? So I'm going to say that since this is our clear plastic cup in the light, that the vast majority of the light goes through our cup to the other side, to the side with the water. Okay. And I'm going to illustrate it with a mostly complete dashed line. If I was looking at a different cup situation, remember we did a cup that was painted black and a cup that was painted white, we're going to kind of get a different situation. So again, I'm going to need to label. This is my ray of light. Okay. This is my cup wall. Here's the water inside. Okay. And what we did to our cup was, I don't know if this will show up, we painted it white, right? So the outside, you cannot see that at all, can you? All right. Maybe we'll just label it white paint. Okay. So what do we know that when we're talking about black, everybody talks about how it absorbs and it warms up faster when it has black paint. But what happens to this ray of light when it hits the white paint? Okay. If you came in for our enrichment class on Friday, you would have been able to play with the light meter and you would see that some of the light is reflected off. So if I'm looking at my key, I'm going to illustrate my some light reflects off with I'm going to label it reflects. Some light reflects. And then a little goes through, right? So a little goes through my cup. I'm going to label that transmit. Okay. So I have a ray of light. It hits the cup wall. Some of it transmits through the cup wall into the water inside to warm it. Some of it reflects off of the cup wall back into the classroom environment. So in this assignment, we're asking you to illustrate with the white cup, the black cup, clear plastic cup in the dark, clear plastic cup in the light, and this one is the foil cup. So you're going to need to illustrate the foil here and think about whether light is reflected, absorbed, or transmitted. Okay, and each of these papers has a question that relates that I need you to also answer. So once you've done this, you can take a picture of it and email it to me, or you can wait to show it to me in class.